Good day, my dear learners. How are you today? Despite the present crisis that we are in, brought about by the COVID-19 virus, it is my prayer that we are all okay in our own convenient and comfortable homes. We have to continue the learning process as this is a lifelong strategy that each one of us must evolve and be involved with. To continue with our lesson for today and for this week, may I invite you again to the lessons that we have passed through last week. Now, may I remind each one of you that we have our objectives. The learner demonstrates understanding of concepts and underlying principles of servicing electrical control and wiring system of domestic refrigeration unit. Let us be focused on the domestic refrigeration unit, which is the entire focus of our course. Under the objectives, we have the different subtask learning objectives. Each one of you must achieve a competent level of skill of all these objectives, which are the following: use correctly the instrument in checking power supply and diagnosing electrical control, check and spec all control wirings as per schematic diagram in line with standard operating procedure, and to accurately diagnose and repair loose connections, wiring, and other defects of a domestic refrigeration unit. Our instrument, which we have to focus, is all about volt ohm meter, or simply known as VOM. Let us try to revisit the definition of volt ohmmeter. It is sometimes called a multimeter or a multi-tester, wherein this is an electronic device that combines several measurement functions in one unit. This is a device that may measure the operating voltage, resistance, and current of a certain electrical component. Here we have a picture of our volt ohmmeter, complete with the testing probes as well as the front view of a volt ohmmeter. Okay, as a sort of a review, let us watch a short video presentation
Alright, so for this segment,
of
I will be discussing to you
how to read a volt
the resistance rating
ohmmeter.
scale of the BUM. The purpose of this video is to help our students analyze how to read the resistance rating scale, which is very vital when testing resistance values of components such as resistors and other resistive components. In my years of teaching, I have observed the difficulty of learners in reading the resistance scale. So we have here the picture of the BUM reading scale, which is very common. I just removed the lower part of the BUM so we can concentrate on the upper side, which is actually the ohmmeter scale. The common question of learners is then how a certain value, for example 5, becomes 10 on this part, while on this part 20 becomes 30 on this part. The answer is simple. Spread out the value per scale. Alright. We also have here letters A, B, C, E. These are actually representations of pointer. So we have here pointer A, pointer B, pointer C, and then pointer D. Alright. So let's have some readings. Okay, example, this is 0, this is 5, meaning this is 1, this is 2, this is 3, this is 4, and this is 5. For the case of 5 to 10, this is 6, that is 7, that's 8, that is 9, 10. Alright, so same as true with the case of 10 to 15, and then 15 to 20. Per scale is counted as 1. Alright, for the case of 20, 30, 40, and then 50, per scale is counted as 2. So let's try. 20, It's 22, 24, 26, 28, and then 30. Same as fluid, 30 and then 40, and then 40 to 50. For the case of 50 to 100, first scale is counted as 10. So this is 50, 60, 70, 80, 90, 100. Now on this part, for the case of 50 to 100, first scale is counted as 10. So we have 50, 60, 70, 80, 90, and then 100. Alright. Now, for the case of 100 to 200, first scale is counted as 20. So we have here 100, 120, 140, 160, 180, and then 200. Let's try to find out what are the values of pointer A, pointer B, pointer C, then pointer D. So, pointer A, this is 5, this is 10. So this is 5, 6, 7. So the value of pointer A is 7. Now for pointer B, this is 15, this is 20. So 15, 16, 17. So the value of pointer B is 17. Now for the case of pointer C, let's try to answer. This is 20, this is 30. So this is 22, 24, 26, 28. Alright. So letter C or pointer C is 28. For the case of pointer D, this is 50, this is 60. Alright, that's 70. So pointer D is 70. I hope you understand our session for today. So see you next time. Don't forget to like and subscribe. Thank you.
Okay, so that's our review. How to read the voltmeter scale in the resistance reading scale. Now, as we proceed, may I invite you again to the parts of our voltmeter. This is our actual voltmeter. Here we have the two test probes. The first test probe, the black, is connected to the N, which is the common terminal, while the red can be connected to the letter P or the positive, which is also in this area here. Now, before we are going to test for the alternating current voltage setting of our VOM, let us first ascertain the functionality of our instrument simply by setting the selector knob to the ×1 position of the resistance. And we are going to short circuit the two test probes. Okay, now, as you can see, the pointer moves. And we are going to set that to 0, which is the zero resistance condition of having the short-circuited test probes. We are going to adjust our zero ohm adjusting knob. So it is located here at this portion here. Now, after you have gone through with the zeroing of your pointer, let us now go to our lesson, which is all about the AC voltage reading. Now, in the selector knob, as being presented here in our instructional material, okay, under the ACV scale, we have 4 different readings. Here we have the 10, the 50, the 250, and the 1000 volts AC, or just simply written as ACV or alternating current voltage. Now, when we are going to test and determine the operating voltage of our place, our shop room, for example, let us be very cautious and have safety consciousness always in our mind, because we are dealing with a voltage that may endure or at worst may even cause death. Let us always assume that every connection that we are going to test is a live connection. So therefore, let us be very cautious in doing this. Now, for example, if I have in here a convenience outlet, and I am going to test the operating voltage of this convenience outlet, first, I will have to set the selector knob to the ACV area. I could have set it to 10, to 50, to 250, or 1,000. But what is the ideal setting for this? It would not be ideal for 10 because we all know that our current or present voltage rating in our area is rated at 220 volts AC. So therefore, if we are going to set this at 10 ACV, the measurement will just simply destroy our VOM. We could not also set this at 50 ACV because again, it is too low for the current or the voltage rating that we are going to measure. We could have set at 250 or we can have at 1,000. But to have a more clearer picture and more precise measurement of the voltage rating, we are going to set that at 250 volts. Now, this selector knob, we are going to set at 250 volts. Under the scale of our VOM, we have here the red colored scale, under which there is a marking ACV. There is 10, there is 50, and there is 250. 0 starts from here, and the value goes up towards each reading selection. So if this is 250, this would mean that when this pointer reaches at this point here, the voltage rating is 250. If we are going to set our selector knob to the 10 AC volts, this would mean that from 0, if the setting travels towards, if the pointer travels towards this one here, this would mean that the voltage rating is 10 volts AC. And if we are going to have this at 1,000, our basis will be the 10. And we will just simply multiply it with 100. So, 10 would mean 1,000, and 8 would mean 800, 6 would mean 600, 4 would mean 400, 2 would mean 200. Now, as to our present voltage rating in our locality, our service, electrical service provider states that the operating voltage is 220. So we are going to set our VOM in the 250 volts AC. So this line here, we are going to adopt the 250 numerical value here. Now, if we are going to insert now the 2 test probes to the convenience outlet terminal, one must be inserted to the positive side and the other one to the negative side. And always bear that in mind that we should never connect or make a contact with the 2 test probes when we are going to insert that into the convenience outlet so that short circuit will be eliminated or will not happen. Now, before I am going to actually demonstrate to you how to measure the present voltage rating running through our lines here, first, let us make a review here. Now, our selector knob is set at 250 volts. So therefore, this will be the value that we are going to remember and to take basis of. Now, assuming that when the pointer moves to this direction, what would then be the voltage reading of the situation? Since this is 250, this is 200, this is 150, this is 100. So therefore, 100 is the reading of the ACV or the voltage AC. If the pointer deflects to this point here, again, the selector knob is set at 250 volts AC. This would mean that our reading is 150 volts AC. If the pointer deflects at this point here, this would mean that our reading is at 200 volts AC. Assuming the pointer deflects at this point here, in the middle between 200 and 250, so that would mean 225 volts AC. Now, let us have the actual demonstration as to how we are going to measure the live voltage rating of our electrical service provider. Now, may I have the help, please, of one of my key persons? Okay? Now, again, a safety reminder. Always bear in mind that we are dealing with a live voltage. So therefore, it is very appropriate to keep in mind to have the safety first. Okay? First, I would have to set the selector knob at 250 volts AC. Then, I have here the two test probes. Okay? Now, I am going to insert the one test probe on this side here. Okay? It is now inserted. I am going to press so that it will not be taken out of its terminal. Now, the other one, I have to insert this on the other side, any one of these. But it would be most ideal if I am going to place it further from this test probe so that unnecessary contact is or can be eliminated. So I am going to insert it here. See, there is a deflection of our VOM. Okay? Now, let us try to read what is now the reading. As of the moment, the reading is at 215 volts AC. Okay? So the running voltage currently is now 215 volts AC. A little below of 5 volts from the suggested operating voltage as provided by our electrical service provider. Now, first, okay, let us set the selector knob range to 250, and then we are going to get a convenience outlet or any outlet for that matter, and then we are going to put the first test probe to one side of the terminal or the convenience outlet and the other on the other side, putting into consideration always that we should have a distance between the two test probes so that it will not have a contact, so that it will not have a short circuit condition. Okay? By this, okay, you are going to be given the individual instrument. But prior to the reading of the actual voltage rating, which is somewhat dangerous for non-skilled persons or learners. Okay? Always call my attention. And I would be very willing to demonstrate to you individually so that you may have to undertake the return demonstration with the strict observation and instruction by your teacher. You have viewed a video presentation a while ago. We have already known that, how to read in the resistance reading or the resistance scale. It is just the opposite of the voltage reading. Because as the pointer deflects to the right, the reading for resistance becomes 0. While in voltage AC, as the pointer deflects to the right, it becomes higher. Now, more or less, the procedure and process are just the same. Okay, now, in order to gain a little skill and knowledge, practice must always be a factor. But bear it in mind that always the correct practice makes your work perfect. If your practice is full of weaknesses and failures, then the end result will not also be an ideal one. For your summative test, okay, you are going to draw the scale in your bond paper and to make bar lines resembling this measurement here. And for every bar, you are going to determine what value will that be. Under the 10 volts AC, 50 volts AC, 250 volts AC, and 1000 volts AC setting of your selector now. For your assignment, you are going to develop a schematic diagram of the simple electrical layout